Hello, this is 4.3 notes. As always, the learning target, success criteria, this stuff you're going to complete on your own. We're going to start with first vocabulary word, standard form. So this is an example of standard form. AX plus BY equals C, so that's the form where A, B, and C are just constants or just plain numbers. So this would be an example of an equation written in standard form. So we've seen these equations when we are given them and we're putting them on graphs. Now we're going to write them. Generally speaking, when we have equations in this form, it's easy or sometimes easy to write these kinds of equations if they give us word problems or real life scenarios with words. But if they give us a graph or they talk about 2 points on the line or the slope or anything like that, it's typically not easy to just write from this equation. So the majority of what we're going to do is convert from slope-intercept form, which is that, or point-slope form, which are two of the forms that we previously learned. So the majority of what we're doing in this lesson is converting from, so we may write the equation like this and then convert it into this form. So let's look at some examples. Example number 1. It says write the linear equation in standard form, and it gives us this equation y equals 5x plus 1. So we have it currently in slope-intercept form like that, and we want it in this format. First thing we want to do, because sometimes we do have it in point-slope form, so the first thing is get rid of any parentheses if we have them. We don't have that, and then from there we're just kind of reorganizing the equation so that the pieces are in the places that we want them. So this 5x term, or this term with the x, is supposed to go in the front. It should be at the front of our equation on this side of the equal sign, so we need to find a way to move it that way. And the way that we're going to do that is just we're going to subtract 5x from both sides. And I put that x at the very beginning, and whenever I do that, you'll notice that I now have it in the form that I wanted it. My x term is first, my y term is second, equal sign right after that, and then that's just the constant term on the end. So that is our answer. Example number 2, it says write an equation in standard form of the line shown. So we have this line here, and we want it written in standard form. Generally speaking, like I said, unless it's a word problem, it's difficult to just start in standard form. So we're going to start in one of the other forms that we already know how to do. So we start here or start here and then convert it into standard form. So I'm going to actually show you both examples. If you have the intercept, that's going to be a little easier, so we'll start with that one. So we'll say we could start with this format, and we just first write our equation by finding the slope in the y-intercept. We'll notice that it crosses the y-axis right here. So that is our y-intercept, or our b, of 1, because that's right where it touches the y-axis. And then our slope is going to be calculated just by going how far up and how far over. We notice the line is going up, so we know it's a positive slope. And then our distance here, or change in y, or vertical distance, is 1. And then our horizontal, or change in x distance, is 1, 2, 3, 4. So our slope is 1 over 4, and it is a positive slope. So our equation is y equals 1/4 x plus 1. That is our equation for this line. That is an equation for this line. And then we go back to our, once we get it on the paper, so that's the first step, we get it on the paper, then we're going to go back to our problem and see what form they want it in. It says standard form, so that means I need to rearrange it. So I'm going to subtract 1/4 x from both sides of my equation and get it rearranged where I have my x term first, my y term next, and my constant term on the end. And then this will be my answer. Now, that's all we have to do. That's all we would do on this problem. But I'm going to show you the other way, the longer way, just because sometimes you do have to use that method if it doesn't give you the intercept, if we just have like one point like this one. So let's assume that we knew the slope of 1/4 and they gave us this point, 4,2, and that's all they told us. So they told us slope is 1/4 and the point is 4,2. If that's all we had, we would have to start with, we'd have to do the long way. So we would have to do y minus the first y equals m times x minus the first x. In this case, the first y is 2, so I'd have y minus 2 equals 1/4 times the quantity x minus 4. Then I would distribute, and I would get 1/4 x minus 1. And over here, y plus 2. From here, I would need to subtract 2. And I get y equals 1/4 x minus, sorry, that's a minus, so that means I'm adding 2. So plus 1. And then subtract 1/4 x. And I would get negative 1/4 x plus y equals 1. So, again, this is how we would do it. Obviously, this is much shorter, and that's the preferred method if we can do it. But sometimes they only give us 1 point, and it's not the intercept. And if that's the case, we have to do this longer method. Example 3. The graphs of the two lines shown are right. The graphs of two lines are shown. Write an equation of each line. So I'm going to color one of these lines red. Call that the red line. And I'm going to color one of them black. And we'll call that the black line. First thing you want to notice is that each of these lines moves in only one dimension. So the red line only moves right and left, and the black line only moves up and down. So because we only have one dimension, we're only going to have one letter. So if we move in 2 dimensions, we have 2 letters. 3 dimensions, we would have 3 letters. But in this case, we're only moving in 1 dimension, so we're only going to have 1 letter. The red line, you'll notice, touches the y, but never the x. So we're going to only have a y. The black line, you'll notice, touches the x, but never the y. So we're going to only have an x. This equation will be very short and very simple. X equals some number. So 1, 2, 3, 4, negative 7, something like that. And that's the whole equation. Same with this one, y equals some number. 1, 2, 3, negative 7, negative 14, negative 100, any number. And the way we're going to do that is we're going to kind of look at our line and ask ourselves, what are the, so if we have y equals, we want to know what the y value is. So what is the y value of the point? Or really any point on that line. What's the y value of those points? So if I list a bunch of y values, you'll notice every point on my line, the y is 2. 2, 2, 2, 2. Any point I put on there, y will equal 2. So that's my answer for my equation, y equals 2. Similarly for the x, any point I put on there, the x value is going to be 3. So any point 3, 3, 3, 3, 3, 3, 3. X will always equal 3 on that line. So that's my equation. Example number 4, find the missing coefficient in the equation of the line shown. Write the completed equation. So a coefficient is just the number being multiplied times a variable. So in this case, the coefficient they're talking about is this a. They've listed just an a, and our job is to find out what that number is. And as it turns out, if you have a line, any line, you can plug in your x and your y, and you get you'd be able to find the missing coefficient. So any point on here I could use. So I have a point here, I have a point here, I have a point here, I have a point here. Any of those points, if I were to take the x and the y value and plug them into this equation, I'd be able to solve for a and find my missing coefficient. So that's what I'm going to do. This point was already listed, so we'll just use that one. So 1 is x and 2 is y, so I'm going to substitute for x and for y, and then just solve my equation. Subtract 2 and divide by 1, and I get a equals 2. So that's the answer to the first part of the question. Then it says write the completed equation, and that would be 2x plus y equals 4. Again, I'm just substituting this 2 in for the a and rewriting this equation. Example 5. A banquet room has small and large tables. A small table seats 4 people and a large table seats 6. The guests at the banquet can fill 9 small and 4 large tables. So 9 small and 4 large. First of all, we want to know how many people that is. We know that, let me erase that, let's write it out. 9 small, 4 large. We know that the small table has 4 people, so 9 times 4 is, there's 36 people there. And we know the large table has 6 people, so 4 times 6 is 24. So there's 36 people at the small tables and 24 at the large tables. So if we add those together, that's 60 people total. Okay. Now, part A is asking us to write an equation in standard form that models the possible combinations of small and large tables that the banquet can fill. So in standard form is AX plus BY equals C. So normally we would use X and Y, but we can actually label our X-axis. Let's say we'll label that small, and we'll label the Y-axis large. And so then we can kind of indicate that X is going to be S and Y is going to be L for small and large, if that helps us. So we're going to replace now our equation AS plus BL equals C. At this point, we have to fill in the A, the B, and the C. The C is going to be our total, and the B is going to be the number associated with large, and A is going to be the number associated with small. What I mean by that is we're going to go back up here. A small table seats 4, so that means we're going to have 4S. So for every small table, that'll be 4 people. And a large table seats 6, so we're going to have 6L. So for every large table, it'll be 6 people. And then C is our total number of people, which we previously found to be 60. So here is our equation that models the situation. Next, we want to graph the equation. If we remember from chapter 3, in order to graph these kinds of equations, I just cover that up, solve for S, and I get 4S equals 60, so divide by 4, S equals 15. So I'm going to go to 15 and put a point. Similarly, to find L, it would be 6L equals 60, divide by 6, and L equals 10. So I'm going to go to 10 and put a point. Next, I'm just going to connect my dots. Part C, it says find 4 possible combinations of tables that would work. So we're going to find 4 dots on here, and we'll notice there's a dot here, and let's see, scratch that. Let's see, we want to find a dot exactly in our thing, and it's right here, right here, right here, right here, and right here. So not that one, but we have 1, 2, 3, 4, 5, 6 possible combinations. It asks us just to list 4, so we're going to list those out for 10, 0, meaning 10 large, 0 small, or this dot, which would be 3, 8, meaning, I'm sorry, that's 0, 10, 3, 8, meaning 3 small and 8 large. 6, 6, meaning 6 small, 6 large, or 9, 4, meaning 9 small and 4 large. Or we could keep going, and there are 2 other possible combinations, but they only asked us to list 4, so we will stop there. Please make sure you fill out this as well. Thank you.